Welcome to section 2 for part 6 of the OwlBot project. For the next order of business, I have these speakers here for the OwlBot that have these little JST connectors on them that I need to cut off. I don't have any small connector pins for this size, I just have larger ones. So I'm going to replace these with what I have here. You can see the size differences here. You may not need to do this step depending on what speakers you're using. This is what I need to do, so that's what I'll do next. I'll just go ahead and snip this connector off the speaker here, then split the wires, and then I'll strip their ends. So you can see here, this is that 4-wire connector we made from before in section 1 for the connections to the pins for the speakers to the MP3 player. Those were the R+, R-, and L+ and L- pins of the MP3 player for the right and left speakers. I used a 4-pin female DuPont connector on the ends of this 4-wire connector I made. And you can see the yellow header pins where that homemade 4-wire connector goes for the speakers to connect to the MP3 player. So now what I need to do is strip the ends of these wires on the speaker to add male DuPont connectors on these wires to be accepted into that 4-wire female DuPont connector I just showed you. So each wire of each speaker will have these male pin DuPont connectors on them, 2 for each speaker, the left and right speaker, to connect to the MP3 player via the 4-wire connector on the yellow header pins of the Arduino Shield board we created in section 1 of part 6 of this build. So let's do that next. Okay, we can see here this is what those male DuPont connectors look like once this is done. This will allow me to easily connect and disconnect from that 4-wire connector to the MP3 player on the Arduino Shield board we made. I'm sure there's better ways to do this connection, but this is what I had and what I came up with. I ended up splicing in some more length of wire to the wires of the speakers just to give me more length, because I wanted to be sure that I could place these speakers wherever I needed inside the owl figure I'm using for the OwlBot, since it's pretty tall. All I did was solder the wires together and added heat shrink tubing for protection. So this speaker should be ready to go to be connected to the MP3 player. Okay, I have the setup for the 2 speakers done. The wires have been taped up with electrical tape to keep them together, and the connectors are finished. I'll demonstrate what hooking them up to the MP3 player will look like. The only thing that I'm making sure that I do is to match the red and black wires when I connect them. I have the red as the positive wire and the black as the negative wire for both the speakers, and how the 4-pin connector wire is set up to the yellow header pins for the MP3 player. It doesn't matter which speaker I hook up as left or right. Either speaker can be either configuration. So we can see here how the connections for the speakers to the MP3 player on the Arduino Shield board we made will look like. Again, I've left myself plenty of length in my wires to place them wherever I need to on the owl figure later for the finished OwlBot. Okay, what I've decided here is that for the peer sensor output line, it's going to have to go to pin 12. So I'm going to use a strip of yellow header pins here, and since we're not using pins 6 through 12, I just took the header pins that I needed and lined them up on pins 6 through 12. We're only going to be using pin 12, again for that out pin of the peer sensor. I took the Fresnel lens off the peer sensor so that I could see the pin labeling underneath. So we have VCC, out, and ground. That out is the yellow wire, and that's going to go to pin 12. We won't be connecting anything to the rest of the pins. If you wanted to connect something else in the future or add something to the OwlBot, you could, but I just did it this way to make it easier to connect to pin 12 based on the configuration that I have on the board. So I didn't really plan things out, I'm just winging it, so this is how I'm putting it together right now. And for the power, or VCC, which is the red wire, or VCC for the peer sensor, I just took these 3 red header pins here and put them in line with the red jumper wire we put in earlier on in section 1 of part 6 of this build. That red jumper wire goes to VN to the MP3 player, which comes from the 5-volt supply that comes from the Arduino. And then again, I'm just going to use one of these pins we established for the common ground we put in section 1 of part 6 of this build. I'll use one of the ground pins for the black wire or ground wire of the peer sensor, which will connect to the common ground. So in order to keep all the header pins down while I solder them in, because they're just loose here, I'm going to use some tape again. You can do whatever you want, whatever is easier for you to keep it all in place. Again, I'm going to use just regular Scotch tape. It's just to hold it in place for now so that it's not falling out on me when I turn the board over here in a minute. I'll just take another piece of tape and place it over the yellow headers I need to solder in place as well. This tape should hold it in place for when I rotate it over. They're not going to fall out on me. And when I can just try to use my other finger to hold them in place. So now I've got to solder. But before I get into that, you just have to make sure that when you're taping that you're not going to overlap the tape onto where you're trying to solder the pins like I did here. So I'll just kind of move it out of the way, but making sure that the tape is still on the board so I can keep all that down and it's not moving on me. So I'm going to solder here and these pins here. I don't know if you can see that on the camera or not. Okay, so now this blob here is for all the pins for the red header pins, the 3 that I put here. They're all connected together here because we want them all to be connected to the plus 5 volts, which is connected to this jumper that we added from before for the plus 5 volts going to VN of the MP3 player, which goes to this red jumper wire that goes to the smaller red jumper wire tied to the plus 5 volts pin here to where the Arduino will be. So all of that is connected to these 3 red header pins now, and also underneath going to the VN pin of the MP3 player. So these are all connected to each other, but these yellow header pins are all separate. So I didn't connect all these together because they need to go to each of the pins 6 through 12. Again, we're going to use pin 12 for this project, but the other pins will be open here. I just did this to make it easier, and maybe later I would want to add something to the project. I don't know, but for now we're just going to be using pin 12. And that's these individual pins here, this group of pins right here. And those are all connected to the pads across from each other, and these are pins 6 through 12. So pins 6 through 12. So again, these are separate. They're not soldered to each other like these are. These need to be soldered to each other because these are supposed to be all for 5 volts. So we're just feeding off the 5 volts coming in for these, and it also goes to be in on the MP3 player. So that's our plus 5 volts. So what I've done now is added an extra source connection for the plus 5 volts feed going to VN of the MP3 player. I've also added for pin 12 here, that's point E, that traces back to the line for the out pin of the peer sensor. Again, I used the yellow headers for my prototype shield board that run from pins 6 through 12, and pin 12 is labeled as point E in the drawing. I just decided to put the group of plus 5 volt red header pins that we can see here on the shield board. I just put it here, although it's not shown on the drawing here. But we're feeding in from the 5 volts here, so it'll all be 5 volts, like I said earlier, for those red jumper wires, to the red header pins, then to VN on the MP3 player. So next, what I need to do is that I need to connect the wires from the peer sensor. So this VCC is going to be a red wire, the out is going to be a yellow wire, and the ground is going to be a black wire. And the VCC wire, or red wire, traces back to what I've labeled as point F on the drawing. And F goes to that plus 5 volt supply, which will be the red header pins that are not shown in the drawing currently. The out wire or yellow wire traces back to what I've labeled as point E on the drawing, and E goes to the pin 12 connection of the Arduino, which is on the group of yellow header pins that was added to the board earlier. And then ground, or the black wire, traces back to what I've labeled as points G on the drawing, and these points go to our common ground pins on the shield board. And those are these groups of black 90-degree angle header pins that we installed from before. We're using 2 or 3 right now, and we'll have a 4th one available for that ground pin. I also forgot to mention earlier that these pins here, I made sure that they weren't going to hit anything on the Arduino, so I have this other Arduino board here. So this is going to be placed kind of like this. Once we install the other pins along these rails here, they're going to fit inside these holes here, and then we'll slide them through those holes, and they'll rest about so tall off this Arduino board. And I just needed to make sure that these other pins that I didn't plan on having there, that I just recently decided to put there, weren't going to hit anything, like hit this, or I don't know if they were going to hit something like that, but it seems to be just fine and nothing's going to be in the way. So that's something that you need to consider when you're creating a project like this. Just make sure that you have proper placement of pins and that other things aren't going to hit or touch other things. I just wanted to go over this again about doing these DuPont connectors. So here I have a female end, and there's a name for it. This is an SYP female end. So it has the female end there, and this is what it looks like here. There's a picture of it right there. So that's an SYP female pin. Looks like that. So what I do is I have my wire, and I take about, I don't know, 1/8 of an inch or so off the end. I give it a little twist at the end. If it's a frayed wire like that, which you know you're normally working with a stranded wire. So then I take this tool here, which is specifically made for doing this kind of work, for connecting like DuPont connectors or these SYP connectors, whatever you call them. So in this case, I use the 22 to 24 gauge. It's the smallest one on here. And I take that SYP female pin and I stick it in there. And I stick it in there with my left hand, my left fingers. And I clamp down with my right hand, but I'm not, you know, clamping real hard on the handle. I'm just doing it so slightly to where I can hold that female pin in there like this, where it's just in there, where it's kind of sticking out like that, where you want those tabs almost flush to the side of the face of the tool like that, where it's just flush like that. And what we're going to do is we're going to stick that wire in there. I have to get the wire now because I dropped it. I have that wire, and no, it's already frayed again. So I'll twist it just so it's not so frayed at the end. It doesn't need to be perfect. So it's sitting in there flush. I'll take this wire and stick it in there until the sheathing of the wire butts up against the face of that tool there. And then I'll give it a good squeeze on the tool to kind of clamp that wire in there. And then I'll release. And right now, this is what it looks like. It clamped onto that wire, if you can kind of see it there. I don't know if you can. Let me get a better. Where it's kind of clamped, the first part of that female pin connector is clamped around, those little tiny tabs are clamped around that stranded wire in there. So now we need to clamp these two tabs, these larger tabs, around the sheathing of the wire, the red wire. So now I'm going to step it up to the 18 to 20 gauge portion of the tool. It's just a little bit larger than that 22 to 24 hole that we used. So I'm going to use that one, and I'm going to slide this in there until those tabs are just inside. Oops, I'm going to slide it in there until these tabs are just inside that tool. It's kind of hard to look at this and then look at the camera to make sure everything's there. So if I rotate the tool around, you can kind of see that those two tabs are just inside there, just inside the teeth of that tool. Now I'm going to clamp down on it, but I'm just clamping enough to where it kind of seals it a little bit. I'm just barely clamping down on it. Now when it's at that point, that's enough. I don't need to clamp it down as hard as I can, because I just need, so I release it, I just need it to clamp enough to get those tabs to go wrap into that sheathing. And now that I'm looking at it, I could have gone a little bit harder, so all I got to do is stick it back in there where I had it. Make sure it's where I had it, and I'll just clamp it a little bit more. I'm not clamping real hard, I'm just clamping a little bit more, and I'll release it. I just need to get it enough to where it's clamped into the sheathing, just so it kind of stays where it needs to be. So that's all you really need to do. And you might need to adjust the tabs on here, and I use the end of the tool, which is just like an end flat edge that I can use kind of like some pliers. And if you need to adjust, see how that width of that pin is a little fatter or wider because I clamped down so hard it made it wider than the rest of this. It might be a little bit wider here. So in order to make it to where it'll fit into the plastic sheathing later, it may be a little too wide to fit inside the holes of one of these plastic retainers here. When you have to stick it in here later, it might be a little too wide where I had clamped down onto those tabs. So I'll just take this flat end of the tool, and if I need to, I'll just kind of, not real hard because I don't want to damage anything, I just clamp it just a little bit. Oh, it slipped on me. But I'll clamp it just a little bit to where I can get it to where it can slide up in. I can get it to where it will slide up in this hole more easily for me. Okay, well, when I get this in this kind of position like this, and slide that in here, like, if I can get it to focus like this, I'm gonna slide it, I can get it in there, and we should hear like a click sound telling us it's all the way in there. Sometimes it can be kind of finicky to try to get in there, and then and it's in like this. Just takes a lot of practice. I'm by no means an expert in doing this. I have to take my time every time, and I tend to mess it up a lot of the times and have to redo it. But just keep practicing at it, and you'll eventually get the hang of it. As you can see here, I ended up creating some extensions for the wires coming from the pins of the peer sensor, so that when I place all the circuitry into the OwlBot that I am using for the OwlBot later, the wires will be able to reach from the Arduino and its prototype shield board to the peer sensor. All I did was take another 6 to 8 inches of the same red, yellow, and black wire we were using before, and added a 3-pin female DuPont connector housing that could hold all 3 wires together, making sure that the order of the wires matched to the VN, out, and ground pins of the peer sensor. That's the red, yellow, and black wires respectively. I then twisted the wires around each other for better wire management. Then I added a 3-pin male DuPont connector housing at the other end of these 3 wires, so that I could connect the single red, yellow, and black wires with the DuPont connectors I made previously. And each of those have a single female DuPont connector at their opposite ends to connect to the points on the Arduino shield board we discussed earlier for the connection points for the peer sensor. Now we need to move on to soldering the header pins that will match to the Arduino Uno from the prototype shield board. In my case, I happen to be using green header pins, making sure that I match the number of pins needed to align perfectly with the Arduino Uno. To solder the header pins to the prototype shield board, you can use the old header pins placed on a breadboard trick to help keep them in place on the shield board to be able to solder them more easily. I've demonstrated this trick in a video before when soldering the header pins to the MP3 player that we're using for this project here. I believe the title of that video was Trick to Soldering Header Pins to a PCB Module Board. I'll leave the link in a card and in the description of this video below, if you'd be interested in that. I ended up using the tape trick that I showed you earlier in the build, using regular Scotch tape to keep the header pins in place for me to solder them on the shield board. You can use whatever method you'd like and is easier for you. Here's what my Arduino prototype shield board looks like so far after adding the header pins and of course with everything else done so far on it. If you've placed the correct number of header pins in the correct locations, you should be able to line them up and fit the shield board onto the Arduino. You can see here that all my green header pins from the shield board line up and fit into all the female headers of the Arduino Uno. At this point in the build, we have our Arduino prototype shield board all set up, the header pins ready to go on it. We've got the speakers and peer sensor all wired up, connected, and ready to go. Next, we need to move on to creating our secondary PCB board, or daughter board, where we'll connect all the components for the solenoids and DC motor to it. From there, that'll be the board we'll connect the solenoids and motor, and then we'll create our connections from the daughter board to the shield board. Doing this will provide a separation of lower and higher powered components. We'll also connect the secondary battery we added back in part 4 of this build series to the daughter board. Here you see the daughter board, or perf board, or PCB board that I'm using. Its dimensions are 3 centimeters by 7 centimeters. At this point, I'll need to start explaining the other components that I'll need from the prototype circuit on 2D that you see here in the background, that brown art box there. I'll transfer the components as I go from the prototype circuit on 2D to this daughter board I have in this PCB clamp here in front of us. So again, referring to our hand-drawn schematic, this is the daughter board that we'll work on next. This is going to have power coming from the secondary 9-volt battery, and then we have our 0-volt reference of that secondary 9-volt battery here. This is going to be part of the common ground for the entire circuit, and I'm not going to do the connections to the 9-volt power supply just yet. I'm just going to go straight into putting the components in onto the board. We'll have our labeled X1 and X2 solenoids here, and the X1 plus, X1 minus terminals off the X1 solenoid, and the X2 plus and X2 minus terminals off the X2 solenoid. So the plus and minus X1 terminal points are labeled here and here on the drawing. We have our diode, and then we have our MOSFET here. And then the plus and minus X2 terminals will go to the labeled points for plus X2 and minus X2 on the schematic diagram drawing here. We have our diode, and then we have the MOSFET for that setup here. Then we have our DC motor over here on the drawing, and we labeled M1 and M2 for the terminals of the motor here. We also have our capacitor across the motor, and we see those points on the drawing here, the labels for M1 and M2, where we want the motor to connect to on the daughter board. And then we have the MOSFET for the motor control here. And even though it's not drawn on here, the capacitor for the DC motor will need to be soldered across the terminals of the DC motor. We want to place it as close as we can across the terminals of the DC motor. We haven't done that yet, but we will do it later. I've discussed why we want to place a capacitor across a DC motor before back in the ScrubberBot project. The discussion of this was on step 0 of the ScrubberBot project on the Mopbot's website. I'll leave a link in the description below to that information if you're curious. It's a nice way to get kids excited about cleaning the house. So now I take this off. If I'm looking at the hand-drawn schematic, I'm wanting to put, starting with the diode at the very bottom. So just kind of looking at it at this perspective. So I'm starting with this diode here. So I have the cathode of that diode at the 7 column in the row B according to the board. So I'll start there, and then I have the other end of the diode, or the anode of the diode, at column 7 row F. So I'll start with that, and then I'll work my way to the MOSFET, and then the resistor, and then I can work on jumper wires and stuff that will go to where I'm wanting a common ground, which I'll probably put the common ground and the power here on the board itself in first, just using bare solid core wire on the board. So let's get to that next. So like I said, I'm wanting the positive supply of the 9-volt battery to come here. I'm just going to choose this pad here, and then I'm going to choose this pad here for the negative supply of the 9-volt battery, which will also be connected to the common ground. So I'm going to go from here to this column of holes here, which is number 2 column. So I want my common ground, or at least the wire, to go across that column from this pad to column 2, and that will run the span. Now all these holes won't be attached to that, but I'm going to run a solid wire from this one all the way up to this hole here, which is column 2. And then on the back side of this, if it's a solid core wire, it'll run completely on the bottom side from here to here. That's column 2, what I'm calling the front side, from here to here and to this pad. And then the 9-volt battery, the negative supply, will connect to this pad. And then the same for the positive supply on this pad. And I'm using column 8 on this board. No, column 9 on this board. From here all the way up to there. And again, I'm using a solid core wire, which we'll see in a minute. We'll see how all that works. Okay, I've gone ahead and soldered the 2 solid wires that I said that I would use as my positive and negative supply lines for the secondary 9-volt battery of the OwlBot. Looking at this first copper pad here, this is for the positive supply. I cut about an 8-inch length of red solid core wire, inserted one end of it through a through hole on column 9, row B, then inserted the other end of the wire through a through hole on column 9, row W, and soldered the wire in place there. I left a piece of red sheathing on the wire in place just as a color reference for myself as I put the components on the board later, to let me know that this is the positive supply. You don't have to do this, but it can be helpful. As for the negative supply, I did the same setup to it as I did for the positive supply. I cut about an 8-inch length of black solid core wire. I inserted one end of it in a through hole on column 2, row B, and then threaded the other end of the solid core wire in a through hole on column 2, row W, and soldered that wire in place there. I left a piece of black sheathing of the wire in place just as a color reference for myself to let me know that this is the negative supply. Again, you don't have to do this, but it can be helpful. What I'm going to do is kind of work my way from the bottom view of the daughter board I'm working on the drawing of the schematic diagram, starting with the first diode we see there for the first MOSFET to one of the solenoids. I'll grab the diode first from the breadboard prototype on 2D and place its leads into the through holes I've designated for it on the board, making sure that I place the diode in its correct orientation as described on the diagram. So I've placed the cathode side lead at the through hole on column 7, row B, toward the copper pads, and I've placed the anode side lead at the through hole on column 7, row F. Next, I want to take the MOSFET associated with the diode that I've just set on the board. This is an RFP30N06 MOSFET, and we need to make sure that we place it in the correct orientation, of which you can see where I've labeled for the gate, drain, and source pins in the drawing. Looking at the MOSFET directly with its labeling facing towards us, or the drain flange or metal tab with the hole in it facing away from us, we can point out the gate, drain, and source leads. So on the drawing, I made it to where it goes drain, gate, source, but the pins of the diagram goes gate, drain, source. So even though it looks like the diode will go to an outer pin or lead of the MOSFET here, according to the drawing, I need the anode of the diode to go to the drain of the MOSFET. So in actuality, it will go to the center pin of the physical MOSFET, but I've drawn it as if it goes to an outer pin of the MOSFET for convenience in the drawing. So we really need to pay attention to what the spec sheet of the MOSFET tells us, what the drawing here is telling us, and how we're connecting our components on the board. Just know that the anode of the diode needs to go to the middle pin, the drain pin of the physical MOSFET, not to one of the outer pins. Pay attention to the spec sheet representation of the MOSFET I've drawn here or on the actual spec sheet of the RFP30N06, not to the orientation of the labeling of the pins of the MOSFET on the drawing I made of the board. Again, so the middle pin is the drain pin, so it needs to be in line with the anode of the diode. I'm placing the drain pin, the middle pin of the MOSFET, in line with the diode at the through hole of column 7 at row G. So the source pin is at column 8 row G, and the gate pin is at column 6 row G. So it needs to be in line with that diode, and I'll show. So we can see I'm making that middle drain pin of the MOSFET in line with the diode here. And this is the anode of the diode going to the middle pin or drain pin of that MOSFET. Now I'm going to move on and transfer the 10 kilo ohm resistor that was connected to the gate of the MOSFET that we just transferred to the PCB board, and place this resistor back in line with the gate of that MOSFET again on the board. So again, this resistor will need to go to the gate of the MOSFET we just placed on the board. We said the gate of the MOSFET will be the left pin of the MOSFET when looking at the front side of the MOSFET, this pin here. So I need one lead of the resistor to go in line with the gate. I'll place it in a through hole next to it. That'll be at column 5 row G, and I'll place the other lead of the resistor in the through hole at column 1 row G, where that end will be soldered to the common ground solid wire we established under the bottom side of this board earlier. So instead of putting this lead of the resistor in line with the gate of the MOSFET, I've placed it next to it, and I'll make the connection in the direction that it is. And the other end of this resistor will eventually get connected to the negative supply rail of the 9-volt battery or common rail on the bottom side of this daughter board. If I turn the board over, we can see that this is that lead of the resistor, and it will be soldered to that negative rail here. And then the next thing to do is the source lead. For the source leads, I was using a green color on the hand-drawn schematic diagram, so I'll just go ahead and use a green 22 gauge solid core wire as my jumper wire from that source pin to the negative supply. So now what I've done is I've placed my green solid core wire in line with the source pin of the MOSFET at column 8 row H, and I've placed the other end of this green jumper wire in the through hole at column 1 row H, where this end will be tied or soldered to the negative supply. And that's where that source pin goes for our green jumper wire. What I'll do now is continue this process with the second MOSFET with the diode, resistor, and jumper wire for it, just like we did to this one. This will be for the second solenoid. So this next one will be done exactly the same, except the diode will be placed with its cathode at row J and its anode at row N, both along column 7 on the board. The MOSFET will be placed with its gate, drain, and source pins along columns 6, 7, and 8 respectively on row O on the board. The resistor will be placed next to the MOSFET at column 5 row O, and its other lead at column 1, row O. And then the green jumper wire for the source pin of this next MOSFET will go from column 8, row P to column 1, row P. I'm also going to go ahead and place the IRF 840 MOSFET for the DC motor onto the board. It's set up similarly to the ones for the solenoids. I'll place the gate, drain, and source pins at columns 6, 7, and 8 respectively at row V. I'll go ahead and place the 10 kilo ohm resistor for it next to its gate pin at column 5, row V, and its other lead at column 1, row V. I'll also connect a green jumper wire from the source pin at column 8, row W to column 1, row W. So I'll go ahead and do that next. Okay, here's what the board for the solenoids and DC motor looks like now up to this point. Don't mind the capacitor there on the board. During all the excitement of putting components on the board and soldering things, I mistakenly soldered the capacitor onto the board instead of across the DC motor terminals. I did this because I was using my own drawing as a reference, but realized later that I had drawn the capacitors shown on the board in the drawing where the motor terminals were to go, instead of showing it across the terminals of the motor. So here we can see where our positive supply will come into the pad here, and the solid core wire that was soldered there for the positive supply on the board. The diode's cathode is soldered to that positive supply wire on the underside of the board, and the anode of the diode runs to the drain of the first RFP30N06 MOSFET. There's 2 of these MOSFETs, each for a separate solenoid. At the source pin of the MOSFET, I've added a green solid core wire that's soldered at the source, and that jumper wire connects the source to the negative supply of the board. I've taken a 10 kilo ohm resistor and have soldered one of its leads to the gate of the MOSFET, and soldered the other lead of the resistor to the negative supply of the board. If I flip the board over, we can see where that negative supply is located. Noting the black sheathing still left on that wire as a reference to the negative supply. We can also see where the positive supply is located on the board, noting the red sheathing still left on the positive supply wire as a reference to the positive supply. Flipping the board back over to the component side, we can now look at the setup for the next diode on the board that is oriented in similar fashion as the previous one. Its cathode connected to the positive supply of the board, and its anode soldered to the drain of the second RFP30N06 MOSFET. At the source pin of this MOSFET, I've added a green solid core wire that's soldered at the source, and that jumper wire connects the source to the negative supply of the board. I've taken a 10 kilo ohm resistor and have added one of its leads to the gate of this second MOSFET, and soldered the other lead of this resistor to the negative supply of the board. Now moving on to the IRF 840 MOSFET for the DC motor. Again, you can see here that I had mistakenly soldered this 0.1 microfarad capacitor here. That's meant to be soldered across the terminals of the DC motor. I'll desolder this off the board later. I'll actually solder a JST connector on this board for the motor connection later in the build. What I'll do is have one of the terminals of the JST connector go to the drain pin of this MOSFET, and the same pin will make the connection for one of the 2 wires coming from the DC motor. That connection is labeled as point M2 on the hand-drawn schematic diagram. The motor will have the 0.1 microfarad capacitor across its terminals, and the other wire of the motor will make a connection to the other pin of the JST connector. This is labeled as point M1 on the drawing, and that will connect to the positive supply of the board. As for the source pin of the IRF 840 MOSFET, I've connected a green solid core wire that's soldered at the source, and that jumper wire connects the source to the negative supply of the board. And then I've taken a 10 kilo ohm resistor and have soldered one of its leads to the gate of this MOSFET and soldered the other lead of this resistor to the negative supply of the board. Okay, earlier in all the excitement, I realized that I had put the capacitor on the board and I didn't want it on the board. I just wasn't paying attention. I was too busy looking at the schematic here. That's probably why I didn't draw it on here originally, this capacitor, because I needed the capacitor to go directly across the terminals of the motor. I want them to get as close. I want to get this capacitor as close to the motor, the DC motor terminals as possible. So now that I think about it, that's probably why I didn't draw the capacitor in this rough draft of a schematic for this project here. But just know that this capacitor here, although it does go across the two motor terminals, M1 and M2, we want to get the capacitor as close to the motor terminals as we can. We want the capacitor to be across, like right up against this back end of this motor, where the terminals will go directly to, the terminals of the capacitor will go directly to the terminals of the motor. Now this was the capacitor I just took out of the board here, and it needs to go as close as it can. Now this one I'm not going to use it because the terminals are too short now, but I'll get another capacitor, and we want this capacitor to be like such. I want it really close to the motor terminals. So I'll get another 0.1 microfarad just like this one, and I'll end up putting the terminals across the terminals of the motor, just like that. But like I said, I removed this capacitor. That's that capacitor there. I removed it from where we had it before on this board, and so it's gone. And now this jumper wire, I don't need it, although I do have this end of this jumper wire helping me to connect between one of the terminals of that plug, this terminal here. I'm having this orange jumper wire now, one side of it, help me connect from this terminal to that's the terminal there. The jumper is in between here, and all that needs to connect to that center pin of the MOSFET, which is the drain pin. So that the other side of that jumper was right here. I just cut it off right down as close as I could get to the board so it's not in the way. So the jumper is really not performing a typical jumper wire function, except for helping me connect that terminal of this connector pin, where the motor will connect in here later, to the drain pin or center pin of this MOSFET. So that's all that jumper wire is doing. So the only thing different now is that capacitor is no longer on the board. I did not want it on there. I just wasn't paying attention. So we don't need the capacitor on the board. We need it as close as we can get, or directly across the terminals of the motor. So that's the only thing I've updated on this board here. And so the next thing I'm going to do is connect the capacitor across the terminals of the motor. And we'll get into the other stuff here. Okay, I've gone ahead and soldered these other JST connectors to the board, those white connectors you see. Starting from the right side, we can see that there's a 2-pin JST connector. That connector is for the X2 solenoid to be connected to. Its pins are soldered at rows C and D on column 4. The middle 2-pin JST connector is for the X1 solenoid to be connected to. Its pins are soldered at rows K and L, also on column 4. And the left 3-pin JST connector is for the wire connections we'll make later for each of the gates of the MOSFETs, the points labeled H, J, and N, highlighted in yellow on the hand-drawn schematic diagram shown on your screen. That connector is to connect each gate to its corresponding connection onto the Arduino shield board we made in section 1 of part 6 of this build, the previous video to this one. So the labels H, J, and N on the drawing correspond to the 3 pins of the 3-pin JST connector, and those pins will get a wire connector we'll make later in the build plugged to them, which will make connections to pins 7, 8, and 9 of the Arduino. Next, I need to make all the jumper wire connections to the JST connectors. Later, I'll go ahead and solder a 0.1 microfarad capacitor across the terminals of the DC motor. And I got a new capacitor here because the terminals of the other one were too short. So this is the capacitor that I'm going to use. Let's go ahead and get some work done. Okay, I have these connectors here. According to the drawing schematic, this would be for plus X2 and minus X2. That's for the X2 labeled solenoid. So these terminals, with the help of this yellow jumper wire and this yellow jumper wire, this one's attached to this pin, this yellow jumper wire is attached to this pin, and they go across the diode here. This is for solenoid X2, this one's for solenoid X1. Again, this terminal is in line with this yellow jumper wire. This terminal goes to this yellow jumper wire, and these terminals are across this diode here, and then this 3-pin connector here is for our HJN points on the schematic, the hand-drawn schematic. So if I start at the H pin here, this pin is connected to this yellow jumper wire here, and the end of this yellow jumper wire underneath the board is connected to this terminal of the resistor, which is also connected to the gate pin of this MOSFET. This middle pin here represents our J point, or point J on the board in the drawn schematic, and that pin is connected to this yellow jumper wire, which is connected to this terminal of this resistor, which is connected to the gate of this MOSFET. And this pin here represents point N on our hand-drawn schematic, and it's connected to this yellow jumper wire, which loops over to here and loops back around and connects to this terminal of this resistor here. And again, that resistor is attached to this gate, to the gate of this MOSFET. So next I'm going to, so that means that this board is prepared at least to have the 2 solenoids and the connections to the Arduino. We still need to put the power supply on here, and we still need to, well, next we're gonna put the capacitor across the terminals of the DC motor. So next I'm gonna take this DC motor and I'm gonna solder the capacitor, the 0.1 microfarad capacitor, across the 2 terminals of this motor. And here again is that capacitor. So I'm going to do that next. Okay, now I've got the capacitor across the terminals of the motor. I got a few burn spots here, but that's okay. I don't think I ruined anything. So now the next thing to do is to put connectors on the ends of the wires of the motor terminals, and I need to make the wires for the connections for the points on, for our HJN points on the board here. So I need to make the wire connect, the wires, and then put the connectors, 3-pin connectors on the ends of those wires for both this board and for the board on the Arduino. So again, now the next thing to do is to put connectors on the ends of the wires of the motor terminals. And I need to make the wire connector for the connections to the points H, J, and N on the 3-pin JST connector. This will connect the gates of the MOSFETs to pins 7, 8, and 9 of the Arduino. All that will have to be done in the next video though, because this one has already gotten pretty long. This has been section 2 of part 6. So the next video will be section 3 for part 6. I greatly appreciate your attention and participation throughout this video and for this OwlBot build series so far. I'll see you on the next one, and remember to keep at it and stay motivated. Thanks for watching.